Hi, in this video I will introduce the adjoint of a square matrix. It will be another square matrix of the same order, and we will create the entries using the original matrix. Let's just see what is the definition. For a square matrix, for an n by n matrix A, the adjoint, or sometimes called the classical adjoint of A, which we denoted by, so we have a notation for that, ADJ, adjoint of A, is an n by n square matrix again, whose ij entry is ji cofactor of A. Okay, so I adjoint of A is given. You're looking for ij entry. Note that I'm switching I and j. This will be ji cofactor of A. Well, if a matrix is 3 by 3, so you have to find 3 times 3, which is 9 cofactor, and then put all of them in this matrix, and we call it the cofactor matrix. Let's see the examples here. Find the adjoint of the given matrices. Okay, so first one is it's a 3 by 3 matrix. 2, -1, 2, 2, -1, 1, and 0, -1, 3. Well, we know that adjoint of A is a 3 by 3 matrix, yes? So we need to find 9 entries. What are these 9 entries? Adjoint A, 1, 1. You have to find a 1, 1. And then adjoint A, 1, 2, adjoint A, 1, 3, and this will continue for. Well, what is 1, 1 entry? 1, 1 entry is 1, 1 cofactor of A. 1, 2 entry is 2, 1 cofactor of A. And 1, 3 entry of adjoint is 3, 1 cofactor of A. And we know what is the formula for the cofactor. It's -1 to the power 1 plus 1, determinant of submatrix 1, 1, which is -1, 1, and -1, 3. This is -1 to the power 2 plus 1, determinant of 2, 1 cofactor. So this is 2, 1 submatrix, which will give us -1, 2, -1, 3. -1 to the power 3 plus 1, determinant of -1, 2, -1, 1. So you find these entries, yes. This needs a lot of work, I know, but well, you find that. So this is -2, 1, and 1. Yes. Well, and then you continue finding more of them. I already have these entries, so I won't. Let me just write again. IJN3 is Ji cofactor of A. And if you do all the computations, it's a very good practice at this stage. You do find all the other entries. You see 1 1 was -2, I just found. 1 2 entry is 1, and 1 3 entry is 1. You can pause the video at this stage and try to make sure that you can compute the other cofactors and complete this adjoint, which is this one. Okay. Well, this in the case of 2 by 2 matrices is much simpler, and you can find it easily. So here, let us do this one. So adjoint here in this case of A is going to be a 2 by 2 matrix, and it's going to have only how many? Just 4 entries. So we have adjoint of A 1 1, which is 1 1 cofactor of A, and this is a -1 to the power 1 plus 1. You see, submatrix here is just a number, and determinant of that is that number. Yes, so it's 1 by 1 matrix. So this will give us just 2. Adjoint of A, entry 1 2, is 2 1 cofactor, and this is -1 to the power 2 plus 1, and determinant of it is 2 1 cofactor. You see 2 1 cofactor, that will be 2 there, and then this is -2. Adjoint of A, the entry 2 1 is 1 2 cofactor of A, and this is -1 to the power 1 plus 2, and well, determinant of 1 2, so this is 1, this is 2. The submatrix is -1, and there's a negative sign. This will give us 1. And adjoint of A 2 1, the entry 2 1 is 2 2, sorry, 2 2 is 2 2 cofactor, which will give us -1 to the power 2 plus 2. So we are doing this guy. This is determinant of 3, which is just 3. If we put all these ones here, this is 2, -2, 1, and 3. So if you notice, if you check this carefully, what you notice is that, yes, in 2 by 2 matrix, finding adjoint is basically you interchange the entries on the main diagonal and multiply off diagonal entries by a negative sign. That is in general, so this is just a remark, and it's easy to find. For 2 by 2 matrices, adjoint of A1 1 A1 2 A2 1 A2 2 is you interchange the entries on the main diagonal and multiply off diagonal entries by a negative sign. Okay. So these are just the definition. You need to do a little bit of practice, and then in the next videos you will see why this adjoint matrix is important.